Good morning, everyone. This is Penny from Wisconsin Land and Water, and we're going to get started with the Concrete Construction Inspection Primer for the 2018 construction season webinar. Today our presenters are going to be Drew Zelle, Travis Buckley, and Joe Van Hulle. And before we begin, I'm just going to go through some logistics with you, and you may know these already, but I got to go through them in case we have new people. So on your GoToMeeting drop-down box, there's a double arrow up on the top. If you click on that, you can minimize the GoToMeeting box so you can see the presentation better. We're asking everyone to mute themselves, and if you haven't, I will mute you so we don't get any background noise. And how we're going to handle it today, we're going to take questions through the chat line. So there's a chat box there, and you can just type in your questions and send them to everyone. And then we'll be looking at those and addressing those at the end of the presentation. So again, we had the three presenters, and at the end, we'll answer all the questions in the chat box. So please use that. We're going to be recording this. It's being recorded. So once it is converted over, we will post it on the Wisconsin Land and Water website so you can watch it at any time. And at the end of the webinar, I'm going to send out a link through the chat drop-down box and for a short survey that we would appreciate you filling out. And also today we're offering one PDH and also the soil and water management CEUs. So at the end of the webinar, if you just want to email me, and my email is penny@wisconsinlandwater.org, and I will send you a PDH certificate if you need that, or I will get you sent in for the soil and water management CEU. I think that's about it. I will turn it over to Travis.
All right. Thank you for taking some time this morning. My name is Travis Buckley. I'm the DATCP area engineer for Northeast Wisconsin. And basically this morning, we're just going to take a little bit of time to go through some concrete material stuff, concrete mixes, batch tickets, basically just a kind of a precursor for some of the concrete inspection stuff and a training that we're going to be doing next week. So I guess with that, we will get going. First thing we're going to talk about, I guess, our reference point for this whole presentation is Wisconsin Construction Spec 4, which is our concrete spec. That's basically what we're going to be discussing today and then the requirements within that. The latest version is December 2017. So if you're working with this standard, make sure that you are referencing the most current version. If you need to get the most current version, you can find it under section 4, the Field Office Tech Guide, which is out on the Wisconsin NRCS website. All right, so first thing we're going to talk about are some materials that are in Spec 4 and the requirements with those. First one, obviously, Portland cement. Basically, we need to conform to ASTM C150, and the standard allows you to use type 1, 2, or 3. Now, typically, we're dealing with type 1, which is just kind of your general purpose cement. Type 2 is sulfate resistant, and then type 3 is the higher early strength. This is an example of a material certification report that you're going to get with a mixed design from a concrete supplier. Usually in our area, for what we deal with, you're going to have type 1 and 2 are going to be on the same certification form. Type 3 really only comes into play in cold weather type stuff, and usually you're looking at doing an admixture as opposed to type 3. I've never seen type 3 used on any of the projects that we do. But basically this is the certification type form that you're going to get from a supplier. So make sure that you have type 1 or type 2, and then documentation showing that it meets that ASTM C150. All right, fly ash. Fly ash is the most common supplementary cementitious material that we're going to see. And basically, it's just a byproduct of coal combustion from the electric power plants. Spec 4 requires that it conforms to ASTM C618, and it needs to be Class C or Class F. What Class C means is that it's produced from lignite or subbituminous coal combustion, and the spec requires that you have a loss of ignition of less than 2%. Class F, on the other hand, is coming from anthracite or bituminous coal combustion, and the loss of ignition per spec needs to be less than 6. Again, this is some documentation from a concrete supplier. This is what they're going to have for their documentation, and basically this is showing that we have a Class C fly ash, and it has the required ASTM there as well. So this is the type of documentation that you would need to show that your fly ash meets Spec 4. The other common supplementary cementitious material is the granulated blast furnace slag, or slag is usually what we just call it. This is a byproduct from production of iron during the steelmaking process, and this needs to conform to ASTM C989. Again, this is typical documentation that you would get from a concrete supplier, and again, we're looking for is this ASTM met, and on this one it's down at the bottom here, but you can also see, you know, some of the other material breakdown there in the chemical material information. Obviously, water is a main component of concrete because it causes the hardening of concrete through the hydration process. Usually, from our suppliers, we're looking at a well or municipal source for our mixing water. The spec requires that the water needs to be clean and free of things like oil and salt and alkalis and organic matter, which usually isn't an issue for us because we're typically dealing with well or municipal sourced water. But the big thing is make sure that they're using clean water. And a lot of times on a mixed design, they'll actually specify what the water source is. All right, aggregates. Aggregates are broken into fine and coarse. And aggregates are important because that really gives your concrete that long-term performance that we're looking for. When we talk about fine aggregates, or say fine aggregates, we're talking about sand. And then coarse aggregate is gravel or crushed stone. Both of those need to meet ASTM C33. They both need to be clean, good, hard, durable materials. And the big thing is that they need to be free of clay and coatings, because we want that good ability to incorporate into the concrete. All right, Air-Entraining Agent. This is another material that's in Spec 4. Basically, what this does is incorporates air into the concrete mix, basically through tiny, minute bubbles. And the reason that this is in our concrete mixes is it improves our freeze-thaw resistance, which is obviously an important property. And this needs to conform to ASTM C260. And this is just an example of an air-entraining admixture that we've seen. Obviously, there's many products out there. This is just an example, but basically we're looking for, you know, this ASTM C260 certification, and this is the type of product data that the concrete suppliers are going to have and be able to provide to you. All right. In addition to the air entrainment, we also have some other admixtures that we run into quite a bit. Basically, all the other admixtures that we're going to run into need to meet ASTM C494, and then there's several different types. If you're familiar with Spec 4, There's a whole list of stuff. But basically, you can break them into 3 different groups. The first one is a water reducing admixture. Basically, this increases the workability of the concrete without having to increase the water content. And once you get into the high range water reducers, those are the super plasticizers, which are pretty common. And as you get further into the spec, you'll run into requirements for super plasticizers when you get into things like walls and concrete drop heights. We're not going to get into that right now, but just be aware. And then the other type are retarding admixtures. These are used to extend the period concrete remains plastic. So basically we're delaying the setting. These are valuable when you get into a hot weather concreting situation where your concrete is setting up very quickly and you need to obviously slow it down a little bit. The other type are the accelerating admixtures. These basically work the opposite. You're looking at accelerating the setting time and the strength development. And where these are going to come into play are during cold weather situations where you need to speed up that concrete setting. And one thing to note, calcium chloride or any admixtures containing calcium chloride cannot be used per Spec 4. And this is just an example of just a product sheet that you're going to get for your different admixtures. This happens to be an accelerating admixture, and it blatantly says in there, non-chloride, and then it gives the ASTM C494 and then the type. So this is the type of documentation that you would need if you are going to have an admixture in your mix to ensure that it meets spec. All right, Spec 4 under the materials section also has information on a few other materials that we're not going to get into today. It has an ASTM for the reinforcing bar, an ASTM for the welded wire reinforcement, as well as curing compounds. So, like I said, we're not going to get into those in this presentation, but just be aware that that materials section does have those 3 included as well, in addition to what we've already talked about. All right, so now that we've talked about materials, let's get into the actual concrete mix design itself, which is kind of putting all those materials together. Now, the first thing we need to talk about is the water cement ratio. And you'll also note that the standard or the specification also has the water cementitious material ratio as well. Usually, in conversation where we only talk about the water cement ratio, but just be aware that water cement ratio technically is only water, or is only cement. If you add those other cementitious materials like fly ash and slag, you're really talking about the WCM. Now they're, in terms of the specification, they're both the same in terms of what's required, but just it's more of a wordage thing. But basically what water cement ratio or water cementitious material ratio is just the weight of the free water to the weight of the cementitious material, and it's expressed as a decimal. So for Spec 4, it needs to be 0.45, and that's 0.45 basically through placement, so that it needs to be 0.45 even when it's on site. So keep in mind, if you're adding water on site or anything like that, that plays into that 0.45. And it really why we care about the water cement ratio or the water cementitious material ratio is it has a direct impact on a lot of properties of the concrete that we care about, like compressive strength, permeability, durability, bonding to the reinforcement, and then shrinkage and cracking. So this is obviously something that we usually take pretty seriously because it does impact a lot of the properties that we really care about. As far as cementitious material, we need to have 564 pounds per cubic yard or greater of cementitious material in our mixes per Spec 4. Basically, there are 4 options to be able to achieve that. You can have just your Portland cement, so you can have 564 pounds of just cement. You can have cement plus fly ash. If you do that, you're basically the maximum amount of fly ash you can have per weight is 25%. You can have cement and slag, and your slag needs to be a maximum of 30%. The rest needs to be Portland cement. Or you can have all 3. You can have cement, fly ash, and slag. And if you have all 3, you're looking at a maximum of 30% fly ash plus the slag. And then of that, a maximum of 25% fly ash. Now, a lot of times, you know, when we get mixes from suppliers, you know, they'll actually submit, you know, it depends on what they have available, I guess, for material. You might see, you know, one supplier might have, you know, multiple mixes with these different combinations, but just be aware that these 4 options are out there, and you know, the different requirements for each one. Air content needs to be 6% of the concrete volume. That's pretty straightforward. That hasn't changed in quite a while. Slump, which is a measure of concrete consistency, needs to be a max of 5 inches. And then once you have those super plasticizers added, we're looking at 8 inches. And notice that there isn't a minimum. I believe it used to be like 2 to 5, or there was ranges, but now we just have max slumps that we need to worry about. All right, fine aggregate. The requirements for fine aggregate in our mixes, basically we need the oven dry weight to be 30 to 45% of the oven dry weight of the coarse aggregate and the fine aggregate added together. So 30 to 45% of the aggregate in the mix needs to be fine aggregate. That aggregate needs to be well graded, and it needs to meet ASTM C33 or the Wisconsin DOT gradation, which the table out of the spec is shown here. You can see the 2 gradations. This is an example of what you would get from a concrete supplier for their gradations. This particular supplier is actually showing both the DOT and the ASTM, which is kind of nice. Theoretically, you'd only need one or the other, but they show both, which is fine. And then they have actually graphical form as well. So just an example of what you would need to see from the concrete supplier to check the aggregate gradation. Coarse aggregate is pretty similar. Again, we need well-graded material. We need to meet ASTM C33 for that, and it's size 67 gradation. Here's the gradation chart, similar to the fine aggregate. And then again, here's an example of what you would get from the supplier in terms of documentation for that, showing the ASTM and then the gradations. All right, so now that we've kind of talked about the requirements of a mix, let's talk a little more about the actual mix design review. So what you would do if you had a project going on and that incorporated some concrete. So basically the standard says that no less than 7 days prior to the start of concrete placement, the contractor is responsible for submitting documentation of the proposed design mix to you, the technician. And basically what that entails is the mix design information, which is kind of this the second section of the presentation. You know, some of those percentages and things like that is what you would be checking in the mix design, for the mix design. And then documentation for all the materials that are incorporated into the concrete. So that's where some of those, you know, product data sheets for the admixtures or those certifications for the cement or fly ash, things like that. That's where that documentation comes into play. So you really need, you need both. You need to check the actual mix design and the materials that are incorporated in it. So how do you do that? One tool that's out there is the concrete mixture materials information job sheet, which is job sheet 813. This is NRCS's job sheet. It's available again out on the Field Office Tech Guide section 4, which is you can get to off the Wisconsin NRCS website under engineering. But basically what the job sheet does is that it walks you through those sections of Spec 4 with the mixed design and the materials. It's pretty straightforward. You just plug it in. It actually has the specification requirements right on it, so you can very quickly see if something doesn't meet. So this is a nice tool that's out there to assist you if you had to review a mixed design. Another tool that we do up in the Northeast area is our pre-reviewed concrete mix list, and we do this as a tool for our technicians in our area. Basically, what we do is we voluntarily request concrete mix designs and material information from concrete suppliers in our area, and then they're reviewed at the area office, and then we put together a list of the mixes that we've then reviewed. So this is actually our list for this year, our most current ones. You can see we get pretty decent participation. We got quite a few suppliers that participate. Again, it's all voluntary, so that they don't have to. But we've been doing it for probably close to 10 years now. So a lot of the suppliers, it's pretty routine for them. And actually, if we slack on getting the information out to them, they'll actually call us wondering what's going on. So it's a tool that we make available, and a reference we make available. It's posted out on the Appleton Tech Center website, which is incorporated into Outagamie County's land conservation website. So if you're looking for it, that's where it is. Obviously, this is just kind of a point of reference, and Joe's actually going to get into what we need to do in the field to make sure that the concrete mix that is on this list is actually what you're getting in the field. So with that, I will turn it over to Joe.
And just a reminder out there, you can always send in your questions through the chat line, and then we're going to take those at the end. So just send in any questions that you have. Thank you.
Good morning, everybody. This is Joe Van Hulle. I'm an engineer with NRCS out of the Appleton area office. And as Travis said, I'll be discussing batch tickets today. A few of the things I'll be talking about, again, this is referencing the December 2017 construction specification 4. I'll start off describing exactly what a batch ticket is. That's defined pretty clearly in Spec 4. What is the purpose and why do we care? Why do we require batch tickets to be delivered? Why do we look at them? Why do we keep them? Spec 4 also pretty specifically lists what is required to be on a batch ticket, so I'll review that. And then I'm going to go through, I've got an example digital printout of a batch ticket, so I'll go through checking that with the job sheet to make sure that all the requirements of the Spec 4 are met. And then lastly, I'll finish up with just talking about some of the ASTM tolerances that again are included in the spec and that we'll see once in a while shown in the batch tickets. And then the NRCS policy for batch ticket retention. So on Spec 4, the definition of batch tickets is listed right on the first page. The batch ticket refers to the form showing the total weights of all ingredients used to mix the contents of the rotating drum mixer. So total weights of all ingredients and other job pertinent information. So when you get a batch ticket, when you check it, when you keep it, it should have all the weights of all the ingredients used. That's going to be your cement, your water, your admixtures, your stone, and then other job pertinent information like, truck ID, concrete supplier, contractor, location of job, etc. So why is it important to keep batch tickets? Well, it's important to keep a batch ticket and actually look at it and check it, because we need to actually document the concrete mix that was supplied to the job. If we don't have a batch ticket to look at and reference and check, we have no documentation on what was actually delivered to the site and used for our project. We use the batch ticket to verify the mix. Travis talked about the pre-reviewed mix designs that we keep on the Appleton Tech Center website. So we'll want to verify that the batch ticket mix kind of meets what they're telling us 7 days in advance that they're going to use. And then lastly, we'll use the batch ticket to check to make sure that all the other design requirements of Spec 4 are met. So here's a digital printout. I'll use this a little later to work through actually checking the batch ticket, but you'll see there's kind of identifying information located toward the top third of the ticket. We've got the truck number, driver number, we've got ticket ID, load ID, ticket number. A lot of that's just used internally at the batch plant in their software system. The load time, that's obviously important. There's requirements in the spec that relate to that. And then the bottom 2/3, you'll see we've got all the materials, we've got the design quantity, the required quantity, and then what's batched. So we're going to use those batched weights and volumes when we're checking our batch tickets. And then another important thing to note is along the right-hand side, the column called percent moisture. That's definitely going to be important when we're calculating the total batch water that's in the mix and when we're calculating the water cement ratio. And the nice thing about this one, not all digital batch tickets have this, but some of the calculations have been done towards the bottom as far as calculating the water cement ratio and the design water. So this is just an example, and this a lot of times this will be the bottom half of what we'll receive for a batch ticket. So this is kind of the meat and potatoes of what we're going to want to see. This has the majority of all the information that we're going to need. This is the upper part of the batch ticket. So if we're collecting this, we shouldn't be just collecting this. We should be collecting both the top and the bottom. This isn't a complete batch ticket. You can see there aren't ingredient weights on this top half. This is commonly kind of referred to as a receipt. It's not to say that it doesn't have decent information. It has the date, it shows the customer name, delivery address, concrete supplier. You'll see it has the mix design described. It notes that a non-chloride accelerator was used. Then you can also see that the mix was actually heated, which makes sense because the date is in November. So that's the full digital copy of a batch ticket that you might see in the field. Here's another example. It's set up slightly different, but it has a lot of the required information that we're going to need to see on a batch ticket. Some of the identifying information is towards the top. It's got the ingredient weights. It's got the amount of water. The one reason I wanted to show this is this one's set up a little different in that the weights are cumulative for the aggregate and for the cement. So the aggregate, this coarse aggregate, is shown as 16,280 pounds. And the sand is listed as 29,560. That's not the total amount of sand that's in the mix. That's the coarse aggregate and the sand combined. So if you want to calculate the sand that's in the mix, you're going to have to subtract 29,560, subtract 16,280. And the same can be said for cement. So that was something that kind of threw me off with this batch ticket. I ended up having to call the quality control guy, and he was able to easily explain kind of how this was set up. So just another example of a digital printout of a batch ticket. And then we have here, we still see these often enough in the delivered to the field. This is a handwritten batch ticket. It's not to say that it doesn't meet the requirements or that they can't provide these. It's a little more tedious at the batch plant because they have to write all this down for every single load. But here's an example of all the quantities listed that are required. They've got the percent moistures, time it was batched, some identifying information, truck, ticket number, date. So the main take home here is that if we have handwritten batch tickets, that they can be acceptable as long as they meet all the requirements listed in Spec 4. So what are those requirements? Let's dive into what they are. If you've got Spec 4 in front of you, this is in section F on page 5. So the contractor shall obtain from the manufacturer a batch delivery ticket for each load of concrete before unloading at the site. So this makes sense. You're going to need it before the concrete load is unloaded so that we can check it and we can ensure it meets Spec 4, because after the concrete is placed, that's too late if we find that issues arise and it doesn't meet the Spec 4 requirements. It goes on to say any concrete load delivered without a batch delivery ticket containing all the required information shall not be allowed to discharge in any part of the project. So it's pretty specific. We need a batch ticket delivered with each load. We need to get it before the truck is unloaded at the site. If we don't have that, they should not be unloading or discharging that concrete at our project. So that's bullet item 1. Bullet item 2, we're starting to get into more of the specific information that's required to be on the batch ticket. So the job pertinent information, it's got a list here, name of concrete manufacturer, batch plan, purchaser, date of delivery, truck number, amount of concrete delivered, and then time loaded or time of first mixing of the cement and the water. That's important. Some of those requirements are in Spec 4. So as we move along to section II, it talks about what we need to see as far as the ingredients on the batch ticket. We're going to want the mixing water, the free mixing water. We're going to want the percent moisture of our aggregates so that we can determine the free water that's in the aggregate piles that's going to contribute to the batch water in the mix. We're going to need to know the type and amount of cementitious material, your Portland cement, fly ash, potentially slag, type and amount of admixtures. Travis kind of mentioned those, accelerator, water reducer, and then your weights of the fine and coarse aggregate. So this is all in Spec 4. It's all required. We should be seeing this on all of our batch tickets. And then lastly, the contractor is responsible for adding the following information. A lot of times if we're collecting the batch tickets, getting them and checking them prior to unloading, we may be adding some of this information, the inspector at the site. So we're going to need to know volume of water added before the concrete is discharged so that we can determine what the water cement ratio is, time the concrete arrived at the site, and then time that the concrete was completely unloaded. There's requirements in Spec 4 that talk about the total amount of time or the maximum amount of time that can elapse before the concrete needs to be unloaded. Lastly, upon completion of the concrete placement, copies of all batch tickets shall be provided to the technician. So, hopefully we'll have most, if not all, well before the completion of concrete placement, because like I said, if we're not getting them, looking at them and checking them until after it's poured, if we run into issues where the concrete doesn't meet, it's not going to be a good situation. And all these requirements, it would be a really good idea to mention these at the pre-construction meeting. Mention these to the concrete contractor. If you have a representative from the concrete supplier, maybe their quality control guy at that pre-construction meeting, you're going to want to make sure to go through the requirements just so they're aware if they're handwriting batch tickets or if they don't typically include moisture percentages, that it's required that they include those on the batch tickets that are going to be delivered to your job. So now that we hopefully have batch tickets that meet the Spec 4 requirements, the next thing that we're going to want to do when we're on the job doing our inspection is we're going to want to check the batch tickets to ensure that they meet the requirements of Spec 4. So one very handy tool that we have, NRCS has a job sheet 821. It's called the Delivery Check Job Sheet. There's a fillable PDF located in Section 4 of the Field Office Technical Guide. It's going to be right under WCS 4, the actual concrete spec. So that's a fillable PDF. You could print that out, print out copies, bring that to the field, use those to check your batch tickets. There's also a Excel spreadsheet that incorporates all of those data entries and actually does some of the calculating for you. That's going to be on the NRCS website under engineering tools spreadsheets. This comes in handy if we have some sort of electronic device on the site that allows us to use an Excel spreadsheet. All right, so let's just go through checking that first digital printout batch ticket that I showed earlier in the presentation. So the first part of that job sheet is gonna ask for identifying information. So, you know, truck number, ticket number, time unloaded, just general identifying information. So I've got that's kind of outlined in the slide here. That's going to be mainly at the top of the ticket. You'll find some of that information in the top half. Again, this is the bottom half of your typical digital batch ticket. So I'll show a close-up of that. We can fill in project, contractor, manufacturer, date, the mix name. That in our area, that's probably going to correspond to one of the pre-reviewed mixes that's contained on the Appleton Tech Center. Time from batching to discharge. Again, the spec requirement of less than 90 minutes for normal, less than 45 for hot weather. And the amount of yards that were batched and location. The next part of that job sheet is going to be doing calculations on the cementitious weights that have been batched. So we're going to want to find the load size is going to be important again, 9.5 yards. And you can see under the material section that we have Portland cement and we also have fly ash. So the column that we're going to be most interested in is the batched because we're checking what was actually batched. So here we have the cementitious material part of the job sheet. We're putting Portland cement, fly ash quantities in. There's no slag in this mix. So the ratios Travis talked about, less than 0.25 for fly ash to total cementitious material. And then our total cementitious material per yard, the spec says 564. And as calculated per this batch ticket is 565. Also note to the left here in the parentheses, we have must be greater than 558.4. That incorporates the ASTM batching tolerances that are also in Spec 4, so I'll touch on that a little later, but 564 minus, 1% is the batch tolerance for cementitious material, so that incorporates that 1% batch tolerance. Next, we're going to look at the aggregates. Again, we'll want to know the size, the load. We've got our 3/4 crush, that's our coarse aggregate, and we have our sand. We've got our batched weights here. That's going to be what we're after. And then one thing to note is that batched weight, that not only includes the stone, but that's the free water. As shown as this percent moisture, that's also going to be in the pile that they're loading into the truck and weighing. So if we want our true stone quantity, we're going to have to subtract that free water as a percentage of the weight that was batched. So we've got our fine aggregate, we've got our moisture content, so it's fairly basic math. You take your weight times your moisture content as a decimal. That gives us our pounds. There's 8.34 pounds of water in 1 gallon. So that's the math kind of up in this area. And then we've got our fine aggregate weight, coarse aggregate weight, that's just a stone. And then we've got to be within this range for a ratio. Next, we're going to look at our water as that relates to our water cement ratio. So again, load size, we already kind of calculated the cementitious material. Now we're going to add in the water, look at the water. So there's 180 gallons that were batched. It's kind of shown on the right-hand side. And then we've got the free water that was in the aggregate piles that we also just calculated. We'll also have to use our documentation and our discussions with the concrete truck driver to show that no water was added, or if there was water added, we'll have to account for that in our calculations. One other thing, you'll also see we've got admixtures. This one's our water reducing admixture. Then we've got air entrainment shown just above that. And those are also measured in volume like water is. If you ever have any issues where you see an admixture that you're not quite sure what it is, I encourage you to contact the concrete supplier quality control person. They'll be able to pretty easily tell you exactly what that material code means. So now as we're checking our water cement ratio, we're taking that mixing water we already calculated in a previous step, the free water that's contributed in the fine aggregate and coarse aggregate piles. And then we take that, get that into a weight, divide that by our total cement weight. And that's where we come to the water cement ratio having to be equal to or less than 0.45. There's also a section on the bottom of the job sheet. This is going to be more used if you have a quality control person or a third-party testing individual coming out to the site and actually doing some of these measurements. I've had somebody come out and do the air content and slump before, so this would just be a good way to document maybe what load they did the testing on. And I mentioned earlier there's batching tolerances. So this is going to be right between the design mix information and the batching requirements. So this is in the ASTM C94. The main one that you're probably going to see when you're checking batch tickets is the cementitious material, where we're allowed to go plus or minus 1% of the required weight. You should note that even with that tolerance, we cannot exceed 0.45. So they can be a little low on their total cementitious material, but they cannot exceed the requirement of the 0.45 water cement ratio. And then these are just some of the other tolerances that are listed. We've got aggregate tolerance, mixing water tolerance, admixture, and air. We get plenty of questions on this. We've had them at several technician meetings. How many batch tickets do you have to keep? How long do you have to keep them? If it's an NRCS funded job, and probably just a good general rule of thumb for other jobs, we've got this Wisconsin supplement to the National Engineering Manual policy that states all concrete batch tickets for waste management practices and jobs that are class 6 or higher shall be maintained in the file for 1 year. So all batch tickets 1 year. Waste management practices or job class 6 or higher. After 1 year, a representative copy of batch tickets shall be maintained in the file, and the remaining batch tickets shall be required. So we get questions on this representative copy. What exactly does that mean? Well, I don't think it's not really a black and white definition. It's going to depend on a few different things. Are you consistently getting one mix at the job site? Are you getting several mixes? Are there varying weather conditions? I think it's going to kind of depend on that to determine how many different representative copies you're going to need. And then for jobs that fall outside of waste management practices or are less than job class 6, we need a minimum of 1 representative concrete batch ticket. So in summary, batch tickets, they're important. They're required per Spec 4. We should be reviewing these batch tickets as they're delivered before the concrete's placed. We should review the batch ticket requirements at the pre-construction meeting. This is a perfect time because the last thing you want to do is have a batch ticket show up that doesn't meet the requirements, and then you're going to be scrambling. Another thing you should check on is know who to call if issues arise. Two main people you probably want to call: quality control contact for the concrete supplier, potentially the batch plant operator. The nice thing is the Appleton Tech Center, at least for our area, has a list of quality control contacts for some of the main suppliers in the area. So I reference that quite a bit. I print it out, keep that with me on the job site. And then just kind of an overall theme, we should be collecting the batch tickets, the full batch ticket. We need to look at them and we need to be checking them to ensure that the concrete being delivered meets Spec 4. So with all that said, I will turn it over to Drew now.
Thanks, Joe. We're going to switch gears a little bit here. We've talked about concrete mixes and material requirements, and we're going to get into the other key component of concrete inspection. We're going to talk about the new specification called Wisconsin Construction Specification 004-WS, embedded or expansive water stop. This came out in October of 2017, so this will be the first year that this specification was in place. And what it does is it pulls out the requirements of furnishing, welding, placing, installing embedded water, expansive and base seal water stop. It pulls that out of the old Wisconsin Construction Spec 4, and it puts it in its new specification in an effort to put a spotlight and to highlight the critical nature of inspecting, placing, and working with these water stops. So it really makes a point of emphasis that when we do water stop installation, we've got to have measures in place, and we'll get into that as I talk a little bit about. But that's why the specification was done. Let's pull it out of Wisconsin Construction Spec 4 and let it sit by itself because it's important. Again, the scope of the specification consists of furnishing, welding, placing, and installing embedded, expansive, or base steel water stop, and all the material must meet the requirements of the latest edition of the applicable ASTM. You're going to see as we go through this that there a lot of things haven't changed, but there are some key things that have changed. And one of the critical things here is we focus a lot on quality control. And in the specification, we talk about quality control versus quality assurance. And I'm going to go through these in detail. So the construction quality control plan, it's developed by the contractor, it's delivered at the pre-construction meeting. And basically what that says is the contractors had an opportunity to review the plans and said, okay, this is how I'm going to do the water stop placement. This is how I'm going to do the water stop welding. And I'm going to identify the quality control person. We'll get that in the next slide. And we're going to identify the quality assurance person. It forces that contractor to truly look at the plan and say, how am I going to do this? And can I do this? And how can I put decent emphasis on the installation of this water stop? So again, this plan is really start the development of this is when the contractor gets the construction documents, but it is unrolled. There's unveiled at the pre-construction meeting. The pre-construction meeting really has a lot of emphasis in this quality control plan. It's where the meeting of the minds take place and where a lot of discussion happens. The quality control person is an individual, it's an employee of the contractor, could be the landowner, but the key thing with a quality control individual, he or she must have no other duties during placement. Their job is to provide continuous quality control during concrete placement around embedded water stop and to ensure proper placement and consolidation. Again, it's a person that have no other duties during concrete placement. When that water stop is being in place and when the concrete is pouring, that person has no other duties other than to put their eyes on what's going on. It's one set of eyeballs that has no other function but to watch that water stop go in and identify deficiencies and make corrections. Again, it's also an employee of the contractor or landowner. The quality assurance person is another set of eyeballs that's doing exactly the same thing. It provides continuous quality assurance during concrete placement around embedded water stop, ensures proper placement and consolidation. But that quality assurance person is a person under the direction and control of the construction approval, or it could be a third-party consultant hired by the landowner. So in a sense, with that quality control plan, we've got two individuals, the quality control person, the quality assurance individual, with two sets of eyeballs on what's going on with that water stop. We're after the best installation of that water stop that we possibly can, so we can avoid having to do any repair or modifications, which are costly and time intensive. Specification also talks about materials, just as it was in past years. All materials have to be approved by the technician. And the contractor needs to provide manufacturers information showing compliance with the specification. So stuff like what the water stop's going to be, how am I going to weld it, any materials you want to identify that well up front, well before we're thinking about pouring any type of concrete. Materials for embedded water stops, very similar to the past. There are some changes. It's PVC, TPR, or PE, minimum width 6 inches, or according to NRCS standard drawings. Pay attention to the NRCS drawings. There may be some changes. There may be some difference in water stops, but for the most part, it's a minimum width of 6 inches. Max 1-inch bulb size, hollow tubular center, ribbed or dumbbell anchor flange. And this is the big change. The minimum web thickness is 3/8 of an inch throughout the entire cross section. We've gone with a thicker and a beefier water stop in an effort to mitigate some deficiencies in the past. So your water stop this year for projects this year, according to this specification, has to be 3/8 of an inch. Again, 3/8 of an inch, and that is probably one of the biggest substantial changes that you'll see within this specification. Materials, expansive water stop. There's not a lot of changes from the last specification. We're going to use preformed strips or mastic caulk. We're going to use hydrophilic materials that expand when subject to moisture and contain no bentonite, whether that's Sikaswell, Hydrotite, various hydrophilic. There's a lot out there, but the key thing with the expansive water stops, they got to be in non-movement or fixed joints only. The joint can't move. That's not a change from any years in the past. That's kind of the way it's been. Materials, preformed expansion joint and mace seal. There's some new things here. The preformed expansion joint filler, minimum thickness of 1/2 inch. It must be made of sponge, rubber, closed cell foam, or boards containing bituminous materials. Not a lot of application for that. Not a lot of change. This year, we get to use base seal water stop, PVC, TPER, or PE. Minimum width is 9 inches, but they are limited to feed storage facilities, NRCS standard drawings only, and approved pre-engineered waste storage structures. So if it's a pre-engineered structure that we've had in the past, and that is in that package that NRCS approved, we can use that base seal. Otherwise, don't plan on using it on a standard waste storage facility that we're designing. It's really only used for the feed storage facilities with the NRCS drawings, that's a caveat, and approved pre-engineered waste storage structures. Welding a water stop. Again, there's no major change here other than the fact we're dealing with a thicker, beefier water stop that's going to be a little bit more difficult to do. Welding a water stop in the field, straight butt joints, splices only, and must be welded according to manufacturer's recommendations. Manufacturer is going to tell us how we're going to manipulate their product, and we need to follow it. Manufacturer's fabricated water stop intersections shall be provided. In other words, we're looking for those preformed L's. We're looking for those preformed T's, very similar to that we've done in years in the past. You will see, and you may see, more of manufacturer certified contractors who do have the ability to fabricate water stop intersections. But the key thing is they need to do their own water stop fabrications in a controlled environment with a proper manufacturer's equipment. And they need to provide documentation to the technician to show that they are truly certified by the manufacturer to do so. And we do have a couple of contractors that do have that capability. Placement installation. Again, not a lot of changes from previous versions. Embedded water stop, like it has in years in the past, has to be secured in place to prevent displacement. We can't wet water stop. We got to make sure it's held in place, and it can't be displaced during pouring. And it's got to be in place, shown in the location shown in the drawings. We've got to do internal vibration along the entire length of all joints, and the quality control and the quality assurance individuals need to be present. In other words, when you're pouring that concrete and you're vibrating, there are 2 sets of eyeballs on it. Like I said before, that quality control and that quality assurance person should be doing nothing but watching and making corrections should there any need to be made. Embedded water stop needs to be 1.5 inches clearance from the reinforcement and 1/2 the water stop the width of the face of the concrete. No different than in past years. No continuous placement through joints except control joints and form walls when using preformed joint control formers or in control joints as shown on an NRCS approved standard drawing. Again, no continuous placement through the joints except control joints formed in walls when using preformed joint control formers. And there's standard drawings for this, or in control joints as shown on NRCS approved standard drawings. Expansive water shop. This is kind of critical. Follow the manufacturer's recommendations and standard drawing requirements. We're seeing multiple different products out there. It's very important to understand what the product's capabilities are and how it should be used and when it should be used. There are some specific limitations of each individual product. So follow the manufacturer's recommendations. Obviously, don't let the hydrophilic water stop become wet part of concrete. Just it's going to expand and not do what it's designed to do. Make sure you're aware of the expiration dates. Some of these hydrophilic water stops expire. Make sure you're familiar with the takt time and the cold weather limitations. Some have more of an extreme cold weather limitations than others. It's the knowledge of the product. Conversely, then you take the knowledge of your product and that becomes your inspection item. Some of these expansive water stops may require adhesive or other forms of fastening to existing concrete. You might put some hydrophilic paste down. You might be using concrete nails. The key thing, it has to be in place and unmovable prior to the pour. Again, and additionally, and this is critical, follow manufacturer's requirement for bead size. More is not always better for bead size. You have to be very cognizant of the concrete coverage based off the product that you're going to use and not exceed the bead size recommended by the manufacturer. That's it. The specification is 3 pages long. It really pulls out a lot of things out of Wisconsin's construction spec 4. But the key thing here is it really highlights the need for proper quality assurance and proper quality control so we can avoid going into the repair phase. That really pretty much completes the webinar for today. I will turn it over to Penny for questions.
And yes, we have a couple questions that we will pass on to you. Jay's been taking notes for us. Just one.
All right, this is Travis again. We had the question: is there a different concrete spec for 350 concrete versus 318? Obviously, 350 concrete is something new in the new 313 waste storage standard, and the answer to that is no. There's not a different concrete specification. You would still follow spec 4 for 350 concrete. Another question we had was, is there any field experience yet with the 3/8 inch PVC water stop? I am not aware of any, at least in our area yet. We do have a couple projects planned for this summer that have it in the plan. So we will see. We've done some experimental welding. We got some samples of it, and we've been doing some recreational welding out back. And it's twice the material. So obviously it takes a little longer to get melted properly. It's a little more difficult, but it does seem to be possible. So it'll be interesting to see how that plays out in the field with the contractors and things. But yeah, I am not aware of anything yet that has gone in.
Okay, that's all the questions so far. If anybody has any more, send them to the chat line. We'll be watching for them. And just a reminder that if you want to get a PDH or Soil and Water Management CEU, to email me. And again, this is Penny at Wisconsin Land and Water. So my email is penny@wisconsinlandwater.org. Just a reminder that if you're interested, Scott Mueller is going to be doing a ethics training webinar on Wednesday, June 13th from 9 till around 10. We're asking people to pre-register for that training. Scott is maybe going to do some role playing or something, so he may be asking some of you to help with that. So if you could pre-register by emailing me that as well. I'm not seeing any other questions, so this is kind of your last call. I'd like to thank Joe, Travis, and Drew for putting this webinar together for us, and thank you for bearing with us at the beginning with our technical difficulties. Glad we got that figured out. If you ever have any training requests or ideas, let me know. That's what we're here for at Wisconsin Land and Water. Sitcom is to provide training, either webinars or in-person trainings. So With that, I don't see any other questions, so I am going to say goodbye. Thank you.